All right, here you go.
All right. So this is the worksheet that you had yesterday for graphing lines in slope-intercept form. And we'll go through the answers. I mean, it seems weird to say answers when we're talking about graphing, but yeah, I guess it's an answer. So there's a couple of different ways that you can approach these graphing questions. One way that's probably the simplest, I would say, but not always the fastest, is to use a t-chart and a table of values. So if we're using a table of values or a t-chart, all we do is we title our chart X and Y, and then we just pick a couple points. So usually 0 is a good one to pick. 1, and then technically you can obviously draw a line off of 2 points, but we can do maybe 1 more just to be safe. So then we say, okay, so if X is 0, what's Y? Well, if we look at our equation, 1 over 4x minus 1, 1 over 4 times 0 is 0. So y is just going to be minus 1. So that gives us 1 point on our graph. If x is 0, y is equal to minus 1. So we'll do that point right there. Up next, we've got 1. X is equal to 1. So 1/4 times 1 is 1/4. And then we have 1/4 minus 1. So that's, here, let's do it over here. So 1/4 minus 1 is the same as saying 1 over 4 minus 4 over 4. And so that's going to be minus 3/4. Okay. If x is equal to 2, and we can also put this in, so 1 and then minus 3/4. If x is equal to 2, then we've got 2 over 4 minus 1. So that's 1/2 minus 1, and shouldn't surprise you that that's equal to negative 1/2. So I'll do that there. And if you want, you can then just make the line off of that. So we can just say, right. That's close anyway. Sorry, this is not the straightest line.
You can hold it.
Yeah, how do I?
You just draw a line, hold it.
There we go. That's what I want.
Okay, do we want to do it with a table? Especially when there's fractions in there? Not my method of choice, right? It's not so bad when you don't have like a fraction or 1/4 or whatever, right? Or sorry, it's bad when there is a fraction. It's not so bad when there isn't a fraction. But I could give you anything, right?
Mm-hmm. Yep, so for number 2, we're going to try a different method. So we've got y is equal to minus x plus 2. And so what we can do is we can identify a couple parts to this equation that are going to be useful to us. First thing is we've got this minus. So this minus, you can also think of it as minus 1. So we can like rewrite this as y is equal to minus 1x plus 2. That's kind of our multiplier. So every time we move 1 unit to the right, we have to apply a multiplier of minus 1. So we're going to be actually moving downwards in the y direction. And then our other component here is our constant. So we've got our multiplier and then our constant. So the constant is super useful because the constant tells us where are we at when x is 0. So in this case, we have, here, let's make this red, a constant of 2. So if we put 0 into x, we'd see that y is equal to 2. And so our constant we can put right there. So our multiplier then tells us what the slope of this graph is. So it tells us, you know, as we move along, are we going up, are we going down, and by how much? So if the slope is -1, then for every step of 1 in the x direction, we're going to be going down by 1 in the y direction. So we've got that point there. We go down 1, we move across 1, we go down 1. Then we move across 1, we go down 1 again, and again, and again. And then you can just graph based on that. Just like so. So we just use that to start from our y-intercept, figure out the next couple of points along the line, and then we just connect them all up and form our big line. Just want to make it clear, you know, I've put these arrowheads at the end of each line. That's super important because lines are something that goes on forever. A line segment has a defined start and a defined end, but a line in mathematics doesn't actually ever end. And the equation of the line goes on forever. So we show that using those arrowheads. So we can do another example. This one's pretty similar, where we've got constant of 1 this time, and a multiplier of essentially 1. We can write that in. This is like 1x plus 1. So our constant is 1, so we can start there for our first point. And then our multiplier is 1, so we know that when we move to the right 1 unit, we're going to move up 1 unit. So plot a couple points, and then we can plot our line. It's going to look something like that. So just a quick summary, if the multiplier is negative, the graph goes like this. So it goes from the top left to the bottom right. If the multiplier is positive, then you have the opposite, where your line goes from the bottom left to the top right. So you can think of this as having a decrease or an increase. So the multipliers being negative means that the value decreases, and the multiplier being positive, it increases. So how about this one? We've got a constant of 4, but our multiplier is 4/3. So that's, at first blush, that looks like it might be hard to deal with. You know, how are we going to go 1.333 repeating to upwards every time we move 1 unit to the right? Well, we're not going to. So we start off with our constant, plop it there at -4. And then what this fraction tells us, well, I mean, it is true that if we go along 1 unit in the x direction, we're going to go up just a bit more than 1. We're going to be going up 4/3 units. But that's not helpful to us, really. So what we can think of this as is that for every unit, so we use 4 units upwards for every 3 units to the right. So we move 3 to the right, and then we move 4 up, and we can put a point there. Okay, so we're increasing by 4 for every increase of 3 in the x direction. That's how you can read this 4/3 multiplier. And then we can do that again. So we move across 3 in the x direction and move up 4 and get another point. And then, of course, we can form our line. Any questions about that one? That one's a little bit trickier. All right. And of course, you can always do table of values if you're not sure. If you just want to check, you're not convinced that this method works, you can always use table of values. Nothing's stopping you. Number 5 here, we've got a constant of -3. So we can pop that down there. And we know that our multiplier is going to be -3. So that means that if we move across 1 unit to the right, we're going to be moving 3 units down. So our first point's all the way over there. And we don't have any other points we can make if we're heading this direction, but we can consider going in the opposite direction if you like. And of course, if you go backwards 1 unit, then you go up 3 units in the y direction. So that would be another point. And you can have another point there as well. So there's our line again. And once again, it's negative, so it's going to be decreasing. We say that the slope is decreasing. Y equals 4 is a bit of an interesting one, because it's not really in the same form that we're used to, where normally, we'd have y is equal to something times x plus 4. But we can consider this as, the multiplier is 0 here. So the multiplier is 0. So that means that we can start by putting our point, y is equal to 4. Use red as usual. So that's our constant point. And we know that the multiplier is 0. And that actually means that the value is never going to increase or decrease. Nothing's ever going to change. So you can imagine, if y is equal to 4 and x is equal to 10, what's y equal to? Well, it's just equal to 4. If x is equal to 7, y still is equal to 4, because we've just defined it as y has to be equal to 4 always. So for any x value, you can just put 4 as the y value. And that gets us a horizontal line. So if the multiplier is 0, that's a horizontal line. Okay. Any questions about that one? Great. All right. A couple more on the other page. So we've got another one with a fractional multiplier. These are good practice. So y is equal to 3 over 5x minus 1. Means minus 1s are constant. And it means that if we go 5 units across, then we're going to go up by 3. So there's one of our points. If we go 5 units in the other direction, that would mean that we'd be going down by 3. So there you go. There's 3 points. That's plenty to plot the line. So there's our line. Number 8 is another interesting one. It says that x is equal to 5. So this is a completely different way of expressing an equation. In all other cases, we say y is equal to something. But in this case, we just say that x is equal to something. So that means that the y value could be anything. If we don't say what the y value could be, it could be anything. All we know is that the x value has to be 5. So that could be a point where y is equal to 0. But this could also be a point. If y is equal to 4, x is still 5 in this case. And this is another point. If y is negative 5, that doesn't matter. X is still 5. So we'd actually call this a vertical line. Whoa. So if the multiplier is 0, sorry, not the multiplier, if it's in the form x is equal to some number, we'll say a, it's a vertical line. Okay, so if we have something that's of the form y is equal to something, that's a horizontal line. If we have the form x is equal to something, that's a vertical line. Anything else, we're going to have some amount of slope, either going upwards or going downwards. Yeah, so here's another one where y is just equal to a value. So we know from that it's just going to be a horizontal line. And it's going to be a horizontal line at the line y is equal to 3. So y is always equal to 3 in this case. So there's our line. Number 10, 3x minus 2. So we put our constant there. And then we know that for every unit we go to the right, we're going to be going up 3 because our multiplier is 3. So we can draw that in. That's probably enough. And there you go. That's what the line would look like. So this is something that, of course, comes quicker with practice, but hopefully you're getting it. So we've got 2 more. This first one is y is equal to 4x plus 3. So we've got 3 as our constant. And our multiplier is going to be 4. So we don't actually have enough room to do that here. We know going across 1, we need to go up 4, but we don't have enough room to do that. So we're going to say going to the left 1, we go down 4. Going to the left 1, we go down 4. And that's enough points. And then the last one. Y is equal to 6 over 5x plus 5. So we again start quite high on the graph. And we know that as we go 5 units to the right, we'd be going up 6. Of course, we don't have enough space to do that. So we're going to have to go 5 units to the left and then go down by 6. So 5 units to the left, down by 6. And we can only really fit these 2 points in here, but that's okay. You can still make a line out of 2 points. Just becomes more accurate the more points you do. So there you go. That would be y is equal to 6 over 5x plus 5. So does anyone have any questions about any of this? It's all making sense? Graphing is all making sense? So of course you can do any of these with table of values. You can do any of these with the method that I just showed you, which is the method I favor, but whatever you prefer is good with you. So now looks like Mr. Mackay is putting up a new formula. Y is equal to 7 over 3 plus 2 over 5x, if I'm reading that correctly.
Mm-hmm.
And we're going to try and graph it. So find an empty space on the grid paper there.
You guys can pick, like, you can put multiple graphs on the same grid too, right? So
Yeah.
You don't just have to have one line on each grid.
Yeah, especially if you'd have one of these, maybe the y equals 4 one. That's pretty clear if you want to throw some other graphs in there.
That's a hard one, okay? I'd like it harder. I don't know if I can make that any harder. Okay? If you wanted an easier one to practice, we can take these up after. Here, if you need more practice with something like a little easier, then we can go 2x minus 5. an easy one, you can see the difference, okay? Being that this is a pre-IB kind of feeling course, not unreasonable to challenge you with something like this, okay? Maybe I'll give you one of these and one of these or something, okay?
I'll stop the recording.
Yeah.